Hello guys again. So let's get started. I hope you enjoyed this long break. So up next is Mladen. He works at Toy Robotics and he has been in InsurTech industry for like 8 years. Am I correct? And he has launched 3 successful products with his team, and previously he worked in business analytics. So I hope you will enjoy his talk. Let's get started.
Okay, thanks. So, hi everybody. As the nice lady in announcement said, we are working in InsurTech, but we'll not be speaking insurance today too much, but there will be some. Secondly, we don't build robots, although it's called robotics. So there is a good reason behind it. So insurance is a very old industry, and you can imagine people, like average age is 50 plus, whoever is the decision maker. So when we were talking with them about what they expect from automation, it was robotics. So for them, if it's an AI, it's a robot. If it's ML, it's a robot. If it's RPA, it's a robot. So that's the name of the company. So what you can expect from the talk today, by the end of the talk, I just want to paint a picture of how a traditional industry looks like in adoption of a technology. And for you guys to understand how would it be to work in this segment of AI and ML. When we are talking AI and ML these days, it's mostly consumer applications, chatbots like ChatGPT or anything similar. In this case, what we're going to talk about is how are you going to take, let's say, a very bleeding edge technology to a very old and regulated industry. So just quickly to go through the basics of where we work and what's the domain. So insurance, pretty much, insurance company buys uncertainty, right? So they buy risk from you so they can actually pay you out in a case of an unforeseen event, and then they take that money and invest it again so they can earn more, very simply. So is there anybody here who carries any type of insurance in Serbia? You? What type? Private, yes. So that's one hand. Then outside of car insurance, let's say you have to have car insurance, right? Life, smart.
Government provided health insurance.
Great. Now, in US, you have to have insurance for everything. So we have like 3 people here who think about insurance or buy it. Insurance in Serbia is actually very cheap. In US, it's not cheap. So in US, you have to, if you own a restaurant, you have to have your own insurance, you have to have home insurance, you have to have car insurance, you have to have general liability for the restaurant, you have to have property insurance, you have to have professional liability if somebody gets poisoned. A director of a company has to have director's E&O. Without insurance, they don't work, they don't exist. So you can imagine that it's a very lucrative industry, right? So the underwriting, that part is risk assessment. So those are the guys who actually take all the data. When I say all the data, before it was looking at a bunch of documents and deciding what to insure, what not to insure. And there are claims, and that's the moment where insurance companies hate to talk to you guys because that's when they have to pay you out, right? So just for these 3 things to be clear, what's happening now is we have insurance, which has been until like 10 years ago, industry that was working on SAP-like applications, right? So if whoever was programming insurance pretty much was working on configurations of SAP or developing very old server-based applications that everybody used. Why? Because A, it was safe for them, there was not much security concern, and everybody got used to it. So they had 0 innovation, like up until 10 to 15 years ago on any type of scale. Today, what everybody's looking at is, they're even looking at blockchain, although that changed, this is a bit old, they don't want to do blockchain anymore. The only company that tried to do it on enterprise level died 5 weeks ago. But everything else has its footprint slowly, except for AI, which started having a big footprint, not just in insurance, but in finance, banking, and pretty much anything. So what I want to talk about today is you will see how we, on our side, and I can only talk from experience, integrate AI into our applications. And if you work in a company that does that, you can see what type of work is done there and what value does that company provide. What do they want to do on the market? So from here, there was a guy this year, he actually said that this quote, you can read it, the only important part here is the only God knew about. So that's how high a CEO of a huge company. These guys are insuring everything. So that's how he thinks about AI now. So you have a pocket of people who think that AI will change their game completely, and you have the rest of the industry who thinks that actually AI will slowly head its traction and then die. So what happened with the InsurTech AI field? You can imagine why I have this image here. So at one moment, people realized, and startups realized, and big companies realized that insurance is actually a 7 trillion market. Only Lloyd's in London writes trillion a year. So some people say that it goes somewhere from 5 to 10% of world's GDP. So when they understood that they can actually start working and bringing AI technology to insurance, you got this type of a game. In conventions, in pitches, I sit on some Shark Tanks in Lloyd's, and you know, understanding what they want to offer. But you had people who are having just document management systems, and they come there and say, hey, I have some AI in it, so can I sell it to you? Right? So you had people with any type of AI technology just coming and trying, right? But that approach doesn't work for insurance or any type of industry that has a very high regulation benchmark. So what happened past years? You had Lemonade. Anybody heard about Lemonade Insurance? No? So those guys started training 10 years ago, almost 10 years ago, started training their models. And what they tried to promise is you're going to have your claim settled, your money, when you get a damage, you're going to have it in 2 minutes, right? So what happens is they have a very strong neural network, they call it customer cortex, and they have several machine learning models working together. So when you come to them, right, you write to a chatbot, and they have been doing this way before GPT. What they're doing is you write a claim to them, they read it, and they pay out. But what happened? It's all about the data. So what they wanted to do is they use advanced machine learning, which will take a limited data set, and on zero shot start settling claims. And they had, I don't know, a Python, right, coverage in Alabama, and that actually exists. There is a coverage for aliens, for alien abduction. You can get anything in the US. But if they were insuring rentals, so what they calculated is that if a python bites somebody in an apartment, and yeah, that happens, in Alabama, they have that many shots of that happening, like 0.01%. But what they didn't know and what they didn't have in their data set, that a guy will bring a python, put it in the toilet, and make it like a bite, and say, hey, this is a claim, you know, this happens. So the data distorted a lot, and Lemonade, who was actually swearing that they will never work with a traditional insurance company, just started working with one in London, and that's the only way to exist. So that type of challenging does not work. The second type of ML that they were trying to do is, and that's actually very successful, so they use a whole bunch of data sources, like they use telemetrics, they use a bunch of images. You can imagine insurance collecting your data for the last 50 years. They have images, they have conversations, they have emails, they have applications and everything. So one very smart company started, again, way back, building their own proprietary models to recognize the damage on a car that works on a computer vision model. Then they can actually look at these windows, see if they're recessed, what type of a building is it. They use satellite imagery, and they just combine all of that to get to a one number, a risk score. Why there is a pig here? Company in China. So what they did is they had a lot of pig insurance. So you can imagine somebody working in agriculture in China having a pig and they insure it, right? When a pig dies, it doesn't actually die, they put it to sleep and they go for a claim. And that was such a hit on their profit that they started training machine learning models on pig faces. So, or they just take a picture of it dead, they come count the pigs, that pig is not there anymore, they just brought it to another village, sold it. So what these guys did is, when you want to file a claim for a pig that is dead, their AI, with 98% accuracy, determines if it's that pig that they insured. So they come there, take a picture of a pig. A, is that the pig that they insured? And B, is it dead or not? And that saved them a whole bunch of money. So this is a good application of technology over there, right? Now, fraud prevention, and this is something where anybody who is working with any regulated industry, this is one of the areas where there is the biggest growth in the market, right? Recognize if somebody wants to create any type of fraudulent activities. And there is a lot of neural networks working there. They use deep learning techniques, but they have access to the data from the insurers. And there is a company called Shift, a large market cap, and they're like going forward, even despite this downturn in the market, they're making a very successful story. So, again, underwriting. You can imagine this type of risk, and they are going here and saying, hey, this is this type of roof, or it's another type of roof, or this pool has a fence, or it doesn't have a fence, or there was a big hurricane, and there is so much damage on the roofs. And they're building the models to actually recommend to the underwriter whether there is a damage or not. They're using classification models to classify this into something called a class code. They're using NLP to read the claims and read the forms. And they're using computer vision to identify this damage here. So all of that, again, comes with either a single or couple of solutions, but those are here for the last 5 to 10 years. So, moving on. When you look at these numbers, they're completely the same. But leaders of insurance companies, they believe that AI technologies will completely transform the industry. It's like 63%, but it's about 50. But again, they just started using this. And there is only 63 of them who are categorized as beginners. It starts to diminish very much on where it actually, on people who are advanced in usage of AI. Why? So there are a couple of things here. The first thing is there are so many barriers. So when you're thinking AI, you see GPT-4 and you see GPT-3, and you see Germany, you see Italy, everybody banning it. That's even worse when you think about insurance, banks, finance, and all of that. Because in order to even have an inference which can pass the bar of accuracy, speed, you have so many attributes that you need to attach to it. And if you want to go from 0 to 1, it's not like Jasper AI, which recommends. It's not like ChatGPT, where you can talk with it about anything in your life, and it's uncertain, or it's certain, or it's not. It's still fine. You have to go through the regulation, which says, okay, I want to know, when you go to a big company, you want to sell software, and you want to build software for them, you cannot come without the enterprise stack, right? So your startup starts from 0, and it has to go to 100 immediately. The reason being, they will ask you when you say, hey, it's a black box. We don't actually know why it's recommending this. We just gave it your data, and this is what came out of it. But they say, okay, but how did you make that choice? Can we trace it back? If not, where are you keeping our data? Is that data the same data that my competitors are using? So will you use my data that I give you to build a better model for my competitor, right? What happens if this stops? It cannot stop for a second because they're losing, as I said, it's 7 trillion market. You can imagine how much one company writes. So then there is a technology we sat when we were trying to close a deal, we were sitting in a company which had 35 people in the room from all of their departments asking questions about how are we going to make this work, from their chief information officer, chief security officer, chief revenue officer. Will this make money or not? So there are so many barriers in the technology side as well that you need to pass. And then there is a business case where they say, hey, I'm not completely sure because you're working with uncertainty and we work with uncertainty. As you remember from the beginning of the lecture, they buy volatility, but they don't like it. So they say, hey, how are you going to make sure that this actually brings back the money, right? And then there is implementation challenges because in any type of data-driven application, you have to have a target on the far right? You can build the best model in the world. And we started with that, and that's where we made a first mistake in our business. We built a very good software, and what we knew is that it has to be on-premise. Reason being is these big companies didn't want to talk cloud, right? The second thing we knew in this case is it has to just have a very accurate, very smart, very, very tightly formulated JSON that goes out, and they will know what to do with it. What happened is, in 2 months, they just said, we just want cloud. And in 3 months, they said, but yeah, this JSON is great, and it's amazing what you guys are doing. And I'll show you what we're doing a bit later. But they said, I cannot do anything with your JSON. I don't have staff in-house. I don't have systems that have APIs. I literally have zero ROI on this data set, right? So going from 0 to 1 in any type of data application, especially the one that is using machine learning, and if you want to make money in any type of industry, if you want to work with a smart company that works in a B2B, it's going to be an enterprise company. That's where the funding is, that's where the biggest use cases is, and that's where the most of technology lie. Okay, our path. What we wanted to do is we built a text extractor. Now, what we started to think about was how can we get all these documents that are coming in to an insurance company and create a data set out of it, which is useful, and on the far end, turn it into the insight that somebody can use, right? And we started with like AI first SaaS. So what we said, we were going to build machine learning models, and then we were going to build a set of microservices around machine learning models, which will serve a certain use case. And we started, the first use case was get the documents in and turn it into an insight and allow them to go and get their business faster, right? So, as I said, we had to start with a segment. It was small businesses where we can get to the data faster, which were in an unstructured form. So what is an unstructured form? The insurance world thought about it as scans. In the sense of technology, unstructured is any type of a free-form text that anybody can write in any type of language. But we started with structured data. So if you can draw a bounding box in a document and get the data out of that and put it into a proper format, right? That's what we needed to start with. NLP technologies were so far back that you couldn't even imagine. And what's funny is when we started working with these technologies, which is a couple of years back, and training on them, the biggest problem we had is handwriting, right? So the curve that started matching the possibilities of machine learning handwriting just spiked out in the last 3 years, and now it can read handwriting better than human. But before, when we started all of this, handwriting was a problem that you cannot solve. So we said, okay, we're going to use computer vision, we're going to use all these technologies, and what we want to do is we want to get application processed faster by 50%. That's a huge savings for them. And what we needed to have is we want to have 98% accuracy, and that's not good enough. Because on a so much volume, 2% is a lot. But still, it can pass the bar because human makes an error in 3% of the cases, right? And we gathered 10 million emails. How we could do this is we are a part of a group that has a business side of the services organization. We have our products, and we can use the data that come from the business to feed on it, right? And now, we looked at the use cases. What can we build first, right? And how the industry adopts by job function the machine learning models and AI at all. So we started with the problem. We started with the technology we want to use. We want to see what the use cases are. And trust me, in AI, in enterprise, it's classifiers. That's very mature. And that's about it. If you use analytical models, any type of analytical model, you can use Monte Carlo, you can use regressions, you can use all of that, that's fine. But classifiers were at the maturity level where we can use them and not fail, right? And you can see the areas here in the risk space. You see that you can use regressions, you can use Monte Carlo, but classifiers, which were not high on adoption, turned out to be at 99% accuracy for us, right? And we had a lot of experiments to do this. We had a lot of people on this to validate results, to train the models, because without it, you cannot even start working on this. Now, what was our thinking, and what was anybody's thinking when they want to build any type of machine learning model tool, right? So what's something that we can build and that nobody else has, right? So we can say that we can build an algorithm that nobody else has. That's super difficult. That's something that you need a team of researchers working on that, validating and validating. You might end up nowhere, right? Okay, so that's one. The second thing is, can we have data that nobody else has? Well, pretty much, right? We can have data that not a lot of people have access to. But again, there are companies such as us that also have the access to the data. But then the third thing is, okay, if we have that data moat, what's the third thing? It all came back to the same thing as any type of software anybody's building in a SaaS world. It's the usage and it's the distribution. So if we can get to the market faster, serve them predictions, show them it works, experiment with them, that's going to be so much different than just building. So last weeks, we have 200 plus applications coming on top of a platform, on GPT platform, right? We had actually one of our competitors building a GPT model in 2 weeks. That model is when it needs to pass the accuracy bar at 50% because it doesn't have a downstream use case. So you have to be real careful thinking about what are you actually solving for and what's all the rest of the software that works with your machine learning model. It all comes back to that experience and to that value. And of course, there is a fourth layer we were thinking about, and that's what has to happen for us to be an enterprise company. And I'll show you that a bit later. So we work with the clients a lot. We had to train our entire team to know the domain. All our engineers, our product owner, he's here in the audience now, he had to learn all about insurance, and he was super happy about it. Still is, right? QA testers, business analysts, anybody, we talked insurance all day. If that sounds boring, it is. But after time, it becomes very interesting because you're solving problems, right? You guys, everybody in this room, what you do best is you solve puzzles, you solve problems, you find ways to do that. So we allowed everybody to find the best way to a goal. We started with .NET on the side of a software. We ended up with 5 microservices in Laravel, 1 microservice in Go. It's insane. Anybody can build their own solution, but we are very fast to market. And if there is somebody else who knows the code base very well, we might as well do it if we are fast and if we are smart about solving this, right? So we use sufficiently mature technologies. We had to go and be very careful of at which point we get the machine learning model in production, what's good enough. And we just kept learning. We learned with a client. Our first client was an enterprise level client. They killed us. So it was super fun, right? Every week they have 5 more requirements. And every week you learn something new that they just forgot to tell you when we were doing the implementation. Oh, but we have these 1,000 applications on the side that we can also involve. Oh yeah, but it would be great if you can read Excels as well and just get us that data. So, but we had this enterprise mindset from the beginning. Yeah, that's fine. You will always get a pull from a client. But then we had a barrier of our guys saying, hey, but we cannot work like this. They're changing their mindsets every time. We cannot work with a company that doesn't know what they're doing. And then we got them to calls. So our developers are actually on calls. Our data scientists are on calls with clients. It was super important to put them on a front line, to talk to clients, to feel their pain, to understand their pain, and not that it comes from the product or anybody else from the business. And that's how we created that synergy where everybody's really trying to be better than in the past iteration. So a lot of POCs, a lot of pain there. I don't know how, can you read anything here? No? Okay, let me try to do something else. If I do this, is it better? Bit? Yeah? Okay. So as you can see, when a client said, hey guys, we have to go to cloud, we took a lot of time to build the entire stack in cloud because everything was built in cloud native way, but it took us a lot of time to put everything in Azure. And we have 2 pipelines. So the first pipeline above is the machine learning pipeline. So we have a separate data science team that works with the data, and we have 3 machine learning models, each doing its own job. And it's fully deployed to containers. The guys know how to do it on the data science side as well. And what happened there is that pipeline is pushing the inference into the application, right? So those teams are separate, but they just work together on a way that this data has to come into the application layer. So we have a classifier here. So this classifier is a neural network, not too deep, but what it does, it uses 120,000 features on each document to determine whether that document is A, B, C, D, and it's a multi-class classifier, which we extend all the time. We built our own custom labeling tool to do that, and it's all trained on our premise. Reason being is cloud didn't give us what we needed at the moment. Now it might change, but for now we're just training everything in-house. The second thing is the extraction model. So what we do, we get the document, we see which document it is, we push it to the extraction model. Then the extraction model takes care of finding where that data point is, getting it out from an image. And then we have this validation model, which actually puts that data into a proper format so it can be ingested. We have configurations, so you can choose your own data type, data structure, and data format. And we have text mining going through text, and we build some of the models on a field level. So you can imagine 250 fields. One field is a description of business. We work on that field with a separate model to understand what the business is. So everything else is deployed on Azure. And what we do is we have two Kubernetes between the classifier and the way when we get the application, we need to load balance, because when I said requirements on an enterprise level, they told us it has to be done in 2 minutes, each one that gets in. So it's not like when we were talking with clients, they were like, okay, next day is great. We started working, they say, what about 2 hours now? And in last convention, when I was doing presentation to a client, they told us, what about 30 seconds? You can imagine 300 documents coming to your application, and you have to get them out in 3 seconds with 250 data points out of each. I told them no, of course. It will not happen anytime soon. But the thing is, that's how we work. Also, we have a human supervision interface. So in our world, AI doesn't work without people, period. So people have to come behind the model. And if our model raises its hand, somebody has to fix it and retrain it. We don't retrain in production. We retrain async, but still, we have people sitting behind this, correcting the outputs and retraining the model all the time, right? And all of this is then, what we're working on now is we are taking email bodies, we are taking documents, and now we are working on this unstructured text and getting the prompts. That's going to be a very fun journey, but we hope nothing breaks in the next 2 months, and it will. On a client, and then it all comes back to the client endpoint. Any questions here or any comments? I will stop here for a sec. There was a lot of going through this. No? Cool. Going further. Just give me a second so I can come back to present. Cool. Now, we come to the interface itself. So this is where we actually correct the inputs. So you can imagine documents coming in, and our first iteration is a model that works, as I said, classifiers, computer vision, and text mining, nothing else. When I say nothing else, that's a pain. So what it does is it can take any type of text from any type of document, it gets it out, and it puts it into a usable format. After we extract this is just the OCR technology, 4 of them actually, and there is computer vision technology, which is very, very difficult to build. Reason being, it needs a whole bunch of documents to train on and continuously retrain, and it's very, very resource heavy. But what we did here is actually we took time before we came production to build all of this. So, and then if something is, if we are not completely confident in the result, you have an interface here where you can quickly fix it and get it back to a structured input. Okay? And we do this every day. We do this, and we try to make this as, this user experience as seamless as possible. And you can see here, actually, when something is not fully confident, it just raises its hands, and we are fixing it, and we're returning back to the output. Okay? So we have a next thing here. What do we want to do next? So we passed the bar on this one, and that has been great for us because that was the most difficult part of it, right? What we had to do next is we had to figure out what other use cases can we actually cover with technologies that are coming on now and that can bring even more value. Because this is just one step. As I said, we started with 1 or 2 use cases, but we now need to spread them to grow further, right? Just give me a second. This got stuck for a second. Now, we need more advanced classifiers. We need more data. We need to optimize the workflow and make it event-driven. So if somebody gets a certain data point, it has to go to some website. We have to give them that opportunity, because if we don't give them enough software to do that, they will have zero usability from our software going further. We are working on recommender algorithms, and we are building our own now, because when we were deciding on how to do this, we first took the easiest approach. So when you're building for ML today, and whoever wants to play at home with GPT, and whoever wants to build an application on top of it, please go ahead. You can make a lot of money, or you can die trying. But the thing is, there are a couple of ways you can do this. You can either just plug into the API and figure out the pocket of a use case where you can say, hey, you don't have this anywhere else. I'll just give you a nice interface which will call for the results from GPT, returning back to you in a way that you can consume it. And that's one business case. The second business case is you have that big language model or any type of deep learning network or any type of model. And what you do is you build another model on top of it, which trains from the model before, right? You just tune it to the use case, and that takes more time, more effort, more resources, right? And that's the second way you can go about it. And the third way you can go about it is building your own model, right? That's the best way still to win in a market such as ours. And that's where we are going now with our proprietary algorithms. But I think it's very difficult, and it's very uncertain whether it will compete with such a big language model such as GPT, right? But still, it's the proper way to go in the next 5 years at least. And domain language models, super smart thing to do for us in our industry when we are working with with an enterprise content, going to legal, going to any type of healthcare, medic. That's big markets that need these type of solutions all the time, and that's where we are heading out next. Now, when we say this is a true intake automation, it is. Where this is all going for us is how do we get the UX, how do we get our application flows to be most suitable to the end users and allow them not just to be constrained by sending us documents, but sending us any type of format, any type of document that we can read. So, and then from there, we can say, hey, this type of documents goes to this department. We can authenticate, and that's very important. We can make sure that we give them chatbots if they need them to settle some, but again, chatbots not for 100% accuracy, but just to get them closer to what they want to do and then send it to a human. And again, give them predictive analytics. So whenever we are building anything in the business world, start with a dashboard, right? So for them, it's dashboard first, and anything behind that can be whatever. But if they don't have a dashboard, nobody on a C-suite level will buy it. So we give them enough of data in their warehouse or lakes. We have our own lake that we build for them, and they can use it, or we can build particular warehouses for them. And for that, we just surge all of that into their target systems. And what we are doing now is partnering with big enterprise companies who are widely used in insurance, so they can use our software and they can just search the data in. That's a very difficult portion of the work because it requires tight integrations with so many softwares, but it's the only way to give them end-to-end automation, which they actually want. So business, if they're talking AI, they're talking headcount. So even if you're saying that AI will not take anybody's job, it will, right? It's already taking it. For them, if you come to work with an enterprise company, they will say, oh, great, this is amazing. How many people can I fire? Or they call it repurpose. But they repurpose it usually to giving them a notice letter. But for them, it's all about how can they make more money with the same or get the same money with less people, right? So we have to take that ethical step and work on actually creating a better interfaces for people to work on a more cognitive tasks with our technology behind them. Because A, that's the best we can do now with the technology, and B, that's the only way to go to create a true automation, right? So that's about it regarding the first part of the presentation and everything. I just wanted to see, is there anybody here who works in any type of an AI company? Okay, anybody here who wants to work with an AI company? Oh, cool. You, why?
Well, because I work in QA, and I think that AI will help with quality a lot because it's going to understand the problems and foresee them much faster, and that way bring more quality to any software.
So do you want to be a user or do you want to build it?
I want to build it.
Cool, Cool. And that's a very good use case. I can tell you that it's very difficult to build. We have companies that I looked at their demos and everything, but it's still very difficult to do that. Selenium is the king, but there is a lot of smart ways that they're doing it. Now the problem is the compute, but if you can solve for compute, you're great. You're going to be very successful in that. Anybody else? AI? You? Okay, cool. So what I wanted to say here is, whoever is coming to an AI company, we now have engineers who want to start working on actual algorithms and models, right? And for that, there are a couple of roles that you can take in a company. One role that you can take in a company is being a data scientist, right? You can learn how these models work. You can optimize them, tune them, and make them useful, make them better, especially guys who know software, who know a bit of DevOps, who can go take it from here to here. They're very useful in this industry, and everybody wants to hire them, right? And there is research. For research, you have to get back to school, right? You have to go take the master's, take the PhD, and go from statistics to applied mathematics and actually work on developing the models. But what I can tell you is, 2 years ago in insurance and 2 years ago in banking and everything, you were hearing only about cloud, SaaS, how can we get to a pretty interface on the internet. Nobody's actually talking about it anymore. We just hear data. And the only advice that I would have for anybody who wants to work in any type of an enterprise company is get better with data, right? Get better with databases, get better with warehousing, learn a bit about it. Learn about ETLs, learn about pipelines, learn how to get that data into a proper format. Learn about what's the best way to serve it on the front end, right? Our stack internally is, our application is any application. It has a full cloud stack. We have .NET in the back and a couple of other microservices. We have Vue.js up front. But we think all the time about what's the best way to show that data and to make it the most useful, right? From there, if you want to go a step further, when you understand the data, you can try building your models. You can play with it. There are so many tools out there that can help you with this. The thing here is, AutoML is eating industry chop by chop, right? You can produce most of the algorithms that are out there. You can produce them automatically. We actually have a very good startup here, a couple of professors working on an AutoML model here in Serbia, and I'm very excited to see how that will work out. But learn through that, and then get to the next step and get to the next step, because this type of solutions will get more and more widely used, and are going to become a must stack for any type of engineer that wants to work in the industry. Also wanted to ask you, on the other side of the story, not the product, but looking at the dev departments. So who uses GPT to code? No, I'm seeing just a couple of, right? Yeah, and anybody working on business applications? You use GPT on business applications? Okay, cool. So what I heard from one of our engineers, we had a very big release, and he had story points. You guys use story points, right? The stupidest thing in the universe, but you have to use it, right? So yeah, we have story points, and somebody gave it a 5, right? He came back in a day and did it in 3 hours. And I'm not joking. And he implemented it fully. How it works, there is DevOps layer, there is CloudOps layer, there is production. And he went from 0 to production without any errors. It was a wrong library, he fixed it. It was a wrong variable, GPT fixed it. And they worked together for 3 hours to develop that type of an output. So in our world, speed is very important. If everybody's releasing in months, now everybody's releasing in weeks. I spoke with a guy who owns a very big InsurTech company, and he told me the next software that will win, the next software company is the one that can build a full feature in a weekend and release it. And that's how fast stuff is moving. So what we want to do as a company is we want to build that integration between software, and we want to build that integration between data science, and get faster and faster and get smarter and smarter in the ways they work together, right? And serve the proper thing to the end user. So if you ever think about your career, just think about data, think about getting better at databases and everything around that, and think about AI in a way that it can help you and it can help others that use your software. And that's very important. Without use, AI is nothing. So with that, I'll stop for questions. Any questions?
Going back to when you mentioned So you mentioned that Chinese company that's taking pictures of pigs and stuff. I imagine that when we're looking at documents that have written words in them, a human can just come in and say, okay, this is a number 2, obviously badly written, but you know. But when it comes to things that we as humans cannot see or test for without tools that we don't really, know how they work, how do you balance the bias between the human trusting the AI and AI hallucinating when it comes to things such as, insurance and, because we're putting a lot of trust into the software that we cannot test because we don't have ability to see differences in pigs' faces. I can imagine there's other examples, but this is the one that you gave.
So first thing that I would recommend is don't give it any trust. So that's one. AI is an aid. They are always saying an assistant, but it's a tool. That AI, really any type of algorithm, doesn't truly understand anything. It guesses the next sentence or the next letter or tries to build a context outside of what it read. In our world, to be honest, we can test, right? We can test a lot because even GPT was tested. It was fed by a human. So in our world, we can test. And that's the only way to protect yourself from any type of bias. You have to have an accuracy benchmark. Now, there is so many ways to evaluate a machine learning model, but let's say call it precision benchmark that you can get to and be comfortable with anything about that, right? So you cannot promise anybody 100% accuracy. So to your point, ethically, if you talk to GPT now and it gives you an answer on what kind of medicine to use, right, for your illness, don't trust it ever. Don't do it. That's the only protection. Like with any type of software, like it with any type of interaction with a computer. Don't trust it with everything. Trust it with enough that can help you do your job. What's actually curious about this company in China? That company actually, they have 1.5 million employees. No, I'm not kidding. I was shocked when I heard like 1.5 million employees. And a large portion of those employees are insurance agents. So you get those calls probably from, I don't know, Generali, Unica, whoever, calling you, hey, do you want to get life insurance? Hey, do you want to get your casco to us or whatever they're trying to sell, right? And they have hundreds of thousands of these guys talking to Chinese people, right? Of course, because they're in China. But the thing is, they trained their models, and that was 5 years ago, to do the calls, right? And they're calling people, and 50% of their interactions with their end users of insurance now is through a person that doesn't exist in a Chinese. And they trust it because they can, right? What can happen? If it doesn't sell a policy, well, right? Well, we'll look at the model, see what it did, we'll retrain it. But the savings on a far back end of not having 50 seats in your company, just calling people all the time and wasting your money on salary, it's much larger, and they can put up with it for a while until they train and they train and they train, and it'll get to 60, 70. And that's how it works with us as well. We started on, I think what we started with is 85% accuracy, something like that, if you can remind me. And we fought for every percentage. And we told our clients, listen, you have to put up with this for now. We'll put safeties behind this for a while. We'll put more bodies, but it will get better and better. So to your question, if I answered it correctly, don't trust it. That's one. And test it like you would test the code. That's the only way to do it. And you will never get 100% certain. When I say never, we'll see. Anybody else? Okay. Thank you guys for listening.